Imagine a boundary so unique that it divides entire ecosystems. Step over it, and you're in an entirely different world of species with entirely new kinds of plants and animals. Welcome to the Wallace Line, one of nature's most fascinating divides. Today, on Open Atlas, we're going to explore the mystery behind this natural boundary, first proposed by the great naturalist Alfred Russel Wallace, and learn how it has shaped the biodiversity of Southeast Asia and Australasia for millennia. So, what exactly is the Wallace Line? Well, in simple terms, the Wallace Line is an invisible boundary that separates the fauna of Asia from that of Australasia. It runs through the islands of Indonesia, between Borneo and Sulawesi in the north, and Bali and Lombok in the south. On one side of this line, you're going to find the typical wildlife of Asia. Think tigers, elephants, and rhinoceroses. But on the other side, in Australasia, you'll find kangaroos, cassowaries, and other species unique to that region. The Wallace Line isn't marked by a fence or visible boundary. Instead, it's an ecological and biogeographical division. But this line is so distinct that even scientists were baffled by it for centuries. How could neighboring islands have such different species? The Wallace Line was named after Alfred Russel Wallace, a British naturalist and explorer. In the mid-19th century, Wallace set out on expeditions across Southeast Asia, studying plants, animals, and their distribution. Well, during his travels, Wallace noticed something peculiar. The species that he found on the islands west of the line, like Borneo and Bali, resembled those on mainland Asia. But as he moved eastward to islands like Sulawesi and Lombok, he encountered species that were more similar to those found in Australia and New Guinea. This observation led him to propose the Wallace Line in 1859, marking one of the earliest recognitions of biogeography, which is the study of how species and ecosystems are distributed across the planet. While Darwin's work focused on evolution, Wallace's insights helped establish the idea of distinct biogeographic regions, adding a new layer to our understanding of natural history. So, why is this boundary so distinct? Well, to answer that, we need to go back millions of years to when the tectonic plates were shifting and forming the landmasses that we know today. Southeast Asia and Australasia were once separated by deep ocean channels, even when sea levels were lower. This barrier prevented species from crossing easily between the two regions, creating an isolated evolutionary path on each side. On the Asian side of the line, animals evolved in dense forests and jungles, leading to species adapted to these environments, like tigers, monkeys, and a wide variety of birds and reptiles. But east of the line, in Australasia, the environment is quite different. Here, species evolved in isolation, adapting to the dry, open landscapes found in Australia and the surrounding islands. This led to the unique development of marsupials, such as kangaroos and koalas, and the arrival of unusual creatures like the cassowary and the Komodo dragon. Despite being separated by only a narrow channel of water, the Wallace Line acts as a significant barrier. The ocean depth between Bali and Lombok, for example, is so profound that it prevents land animals from crossing. During the last ice age, when sea levels dropped, other islands were connected by land bridges, but the Wallace Line remained a barrier, ensuring that species on either side continued to evolve separately. This boundary has fascinated scientists because it represents a rare example of convergent evolution, where species develop similar adaptations in isolated regions. Marsupials in Australia, for instance, fill similar ecological roles as placental mammals in Asia, but they've evolved independently, without interaction. Wallace's discovery wasn't just a fascinating insight into geography, it was also revolutionary for biology. It helped scientists realize that geography plays a crucial role in the diversity of life. Wallace's work laid the foundation for future studies in evolution and ecology, inspiring generations of scientists to explore how different environments shape the development of species. Interestingly, Wallace was a contemporary of Charles Darwin, and they even communicated about their theories. In fact, Wallace independently came to conclusions about evolution that were strikingly similar to Darwin's, which contributed to Darwin's decision to publish On the Origin of Species. Wallace's ideas about natural selection influenced Darwin's work, and he became a key figure in the development of evolutionary biology. Today, the region around the Wallace Line is known as Wallacea, a transition zone with a unique blend of Asian and Australasian species. Wallacea includes islands like Sulawesi, the Maluku Islands, and Nusa Tenggara, where species from both sides of the line mix in an extraordinary way. Wallacea has become a hotspot for biodiversity, with new species still being discovered regularly. Scientists continue to study this region to better understand how isolation and evolution interact. The Wallace Line's legacy lives on as a symbol of nature's diversity and the intricate balance that maintains it. The Wallace Line isn't just a scientific curiosity, it's also important for conservation efforts. By understanding the distribution of species and their evolutionary histories, conservationists can better protect these unique ecosystems. Both sides of the Wallace Line face threats from deforestation, habitat loss, and climate change. Preserving these ecosystems is essential to maintaining the biodiversity that has evolved over millions of years. Scientists use the Wallace Line to identify areas with distinct ecological value. It serves as a reminder that some places require special attention because they house unique species found nowhere else. As we work to conserve these habitats, the Wallace Line remains a powerful symbol of what makes each corner of our planet extraordinary. The Wallace Line reminds us of nature's complexity and the amazing ways that species evolve in response to their environments. As Alfred Russel Wallace discovered, the boundary between Asia and Australasia is more than just a line. It is a divide between two worlds, each with its own unique array of life. So the next time you find yourself on a tropical island in Indonesia, think about that hidden boundary nearby that separates Asia from Australasia. What other natural mysteries might still lie undiscovered, waiting for explorers to reveal them? Thanks for watching this episode of Open Atlas. If you enjoyed exploring the Wallace Line and you want to learn more about Earth's incredible natural boundaries, well then be sure to subscribe and hit that notification bell. And tell us, if you could cross any natural boundary in the world, where would it be?